changed everything. Really changed everything.
Honey, you're gonna extend that time out?
That.
10, 9, ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running.
Welcome to Boom Department.
The sea still hides many mysteries, waiting to be deciphered, and for centuries, sailors have created myths and legends about terrible things that await in the immensity of the ocean, stories of terror about the depths of the sea. But among all of them, there are some tales that stand out above the rest, stories that sailors from all over the world have told throughout history. Speaking about monstrous waves that appear out of nowhere and are capable of devastating any vessel, along with everything they encounter. Legends about the sea claimed that even in moments of total calm in the ocean, waves more than 30 meters high could appear, rising like immense vertical walls of water that, upon colliding with a ship, would cause its total annihilation. But all of this sounded like simple gossip, just another sea story that sailors gathered together as a kind of legend. Everything we understood about the nature of the oceans and the process of wave formation led scientists around the world to confidently claim that they were merely stories. Monster waves could not exist. When we study waves, we usually follow what is known as the linear model, a mathematical model that allows us to know the average height as well as the maximum and minimum height of waves. Let's imagine that we are in a storm with waves that have an average height of 12 meters, a situation that is already quite extreme. The linear model tells us that, naturally, most waves will be close to these 12 meters, and the further you move away from this value, the lower the probability of finding a wave of that height. So, according to the linear model, the probability that in the context of this storm, a 30-meter wave would arise is 10 to the power of -5. That means that a giant wave like those described in sailors' stories appearing in the sea is, mathematically speaking, impossible. This probability led the scientific community, with the aim of settling once and for all the debate about these monster waves, to claim that if they did exist, they would be so rare that only one would appear in the entire world every 10,000 years. If such waves existed in nature, they would be extremely rare phenomena. And in this way, through mathematics, we believed we had closed the door on these monster waves. But what happened? As always, nature showed us that we were wrong. January 1995, the Draupner wave. In 1995, an oil platform, the Draupner station in the North Sea near Norway, was struck by a storm. A storm that, despite the violence storms can reach in that region, was simply one more among many. Even so, as a simple protocol and for safety reasons, the workers on the platform were confined inside the facilities. No one could see what was happening outside. Fortunately, an external camera was recording everything that was happening. The images showed classic storm waves, nothing out of the ordinary. But suddenly, without warning, a wall of water crossed the frame. A 30-meter wave had just struck the oil station, coming close to causing its destruction. Just like the legend said, it had happened on that platform. An immense coincidence had taken place. That probability of 10 to the power of -5 had come true. It was supposedly the only monster wave that had formed in Earth's oceans in the last 10,000 years, and we had captured it on camera. Or perhaps what we thought was a legend was actually a terrible reality. After the first real evidence of the existence of monster waves, oceanographers around the world were astonished. The wave that was baptized as the Draupner wave marked a turning point that caused the scientific community to reopen the case that had been considered closed, launching an unprecedented oceanographic investigation. If monster waves were real, if perhaps they were responsible for the destruction of ships that we had previously attributed to corrosion or human error, we needed to understand their nature. Many thousands of dollars in maritime commerce were at stake, and when money is at stake, investigations begin quickly. That same year, 1995, the search began, in search of the sea's monsters. Oceanographers looked at where maritime accidents occurred most frequently, incidents that might have been caused by waves like the one that struck the oil platform. All the clues pointed to one destination, the coasts of South Africa. In the previous decade, around 20 cargo ships had been destroyed in those waters. Following the pattern, scientists saw that the accidents coincided with the Agulhas Current, a warm ocean current in the southwest of the Indian Ocean that runs from northeast to southeast along the eastern coast of Africa. Most of the unexplained incidents occurred in areas where this warm current flowed in the opposite direction to winds coming from the South Pole. We knew perfectly well that the process of wave formation is related to wind, and that the warm currents along the coast of South Africa, moving against Antarctic winds, could stimulate the formation of unusually large waves. It did not seem unreasonable. The same conditions could be extrapolated to the North Sea, where we had recorded the first monster wave in history. Once again, we believed we had solved the mystery. To avoid problems with these giant waves, ships would simply need to avoid these regions. But we had only opened the door to revealing a darker secret. February 2001. Horror in the Drake Passage. In 2001, something was about to happen that would make everything collapse again. The Caledonian Star was crossing Antarctic waters. On board, around 100 tourists were enjoying the wonders of the South Pole. It was a ship designed to cross ice and withstand the most extreme conditions. But it was about to face something no one expected. On the return journey, terror was waiting. March 2nd. The captain received a warning of bad weather, a storm that should not pose any danger. No one among the crew was concerned, but everything changed when, at 5:30 in the afternoon, the first officer on the bridge saw something on the horizon, a wall of water. A wave twice as large as the others was approaching the ship at great speed. As the ship approached the wave, it began to fall downward toward an abyss, facing a wall of water whose crest they were unable to see. Then the impact came. The wall of water smashed the windows of the bridge and destroyed all navigation and communication systems. Fortunately, it did not sink the ship. They had survived a monster wave. And all of this had happened in the Drake Passage, the stretch of sea that separates South America from Antarctica, a region where, according to the model applied in South Africa and the North Sea, these giant waves should not be able to form. Perhaps it had been a coincidence, but when, just a few days later, another vessel in that same area was struck by another 30-meter wall of water, putting the entire crew in mortal danger, we had to rethink everything. Two monster waves, separated by just a few days, in a region where we could not explain their formation. It was clear that we were facing a much bigger mystery than we had believed. The revelations of Project Maxwave. Because of this, in 2003, the European Space Agency, in a desperate attempt to understand the nature of these monster waves, launched Project Maxwave, an unprecedented oceanographic study. A satellite took 30,000 images of the ocean surface over 3 weeks, collecting graphical data that allowed scientists to measure the height of waves forming in the seas. The European Space Agency mapped the oceans in search of giant waves. What the satellite data revealed left oceanographers around the world stunned. In just 3 weeks, 10 waves more than 30 meters high had formed in Earth's oceans. We had gone from believing that one formed every 10,000 years to discovering that more than 10 could form in just 3 weeks. So in 2004, when the results were made public, the European Space Agency issued a statement accepting the existence of these giant waves. It was also theorized that the legend behind the Bermuda Triangle might be due to that region frequently gathering the conditions necessary for their formation, although this is still not entirely clear. What is clear is that monster waves are not a legend. Giant waves more than 30 meters high appear out of nowhere, and for no apparent reason. They are a reality, a dark reality hidden on the high seas. What are monster waves? Monster waves, also known as rogue waves or wandering waves, are unusually large waves that form spontaneously, without climatic, oceanographic, or tectonic events that explain their appearance. Ships are designed to withstand undulating waves, the typical ones, but monster waves are not like that. They are a wall of water coming straight at you. They are 3 times larger than tsunamis and do not represent a problem on land because they exist only in the depths of the seas. But they are hell for ships unlucky enough to cross their path. A typical 3-meter wave produces a force of about 1.5 tons per square meter when it strikes a ship. A 12-meter storm wave produces a force of about 6 tons per square meter. But a 30-meter monster wave exerts a force of about 100 tons per square meter. Ships are designed to withstand about 15 tons per square meter. So a monster wave can easily destroy a ship that was considered practically indestructible. But if they were not caused by climatic phenomena or local geological processes, why did they appear? Why did these vertical walls of water rise out of nowhere in the ocean? The answer, surprisingly enough, may lie in quantum mechanics. Osborn, a mathematician at the University of Turin, spent more than 30 years working on Schrödinger's equations. He realized that the equation could describe a theoretical water surface, where enormous waves could suddenly arise from nothing. In this nonlinear Schrödinger model, the possibility that normal waves could become unstable and grow could be considered. But of course, this was in the quantum world. Oceanographers believed that applying this model to the oceans was impossible, so they paid little attention to what Osborn proposed. How could the ocean, with its 510 million square kilometers of surface, be subject to the laws of quantum physics? It made no sense. But that changed when someone sent Osborn the wave profile from that day in January 1995 when the wave struck the Draupner station. The profile was identical to that predicted by Schrödinger's equation. What the nonlinear quantum mechanics model predicted matched the first monster wave ever recorded in history. Perhaps, after all, it made no sense to look for the reason for their existence in ocean currents or strong winds. Perhaps the ocean was subject to the rules of quantum behavior. Perhaps monster waves arose because the sea followed Schrödinger's equation. But, well, not exactly. The rules of quantum mechanics apply to the subatomic world, not to the ocean. Yes, it is incredible that the wave profile matches the Schrödinger model, but the reason for their existence must lie in the very nature of the ocean itself. We must remember that it has only been about 20 years since we confirmed their existence, and although they are not as rare as we once believed, they are still very uncommon, which makes studying them very slow. What is clear is that very special conditions must come together at the same time for a giant wave to form. Apparently, the following phenomena would have to occur simultaneously. A strong current moving in the opposite direction to the surface waves. Constructive wave interference. Waves from different directions combine because they collide at a very specific angle, creating a higher wave. Energy forcing the waves to move against the current. Wind blowing across the surface with very specific intensity and direction. Many rare factors must occur at the same time for a giant wave to form, and it is not clear whether all regions of the oceans can meet these conditions. In any case, monster waves are believed not only to be very rare phenomena, but also extremely unstable waves. They collapse quickly after forming. This would explain not only why they cannot reach coastal areas, but also why, just as sailors' legends claimed, they seem to appear and disappear as if by magic. Monster waves are proof that, once again, reality surpasses fiction. Our planet is a wonderful place, but it also hides secrets that can be terrifying. Who knows what mysteries the oceans still hold? Only time will tell.